So Jaren, okay, both me and everyone else had put you in a difficult situation, right? Because you were always asking for more money, better processor and all that stuff. And I was always telling you, hey, you are not in United States of America, you are in India, right? You're going to build something right from scratch with materials which you can find in India, with your colleagues who are Indians, and this is for Indian domestic consumption, right? But look, robot has come now, and you have built a most remarkable thing in a very low budget. Okay, it is accurate, it sounds good, it can move, it can talk, it can respond, it can take tickets out, it can basically print anything what you want in terms of your travel, it can tell you weather, it can tell you about destination, it can actually in future may bring you a nice coffee also, right? It can also tell you where you are and where you are supposed to go, and be careful. Take all of us, okay, how you have built it, what are the various architectural elements, right from wheels to the brain, which you have built, which anyone who's listening to this conversation, they will get enlightened and they probably will build a lot of robots.
When you build a robot, the thing is, when you design one thing, it's a totally different ballgame when you put it, when you make it in practice. So like when you design one thing, you do it, we don't have much experience. Like if someone has 10 to 20 years of industry experience, they'll know what will happen. So we were going one step at a time. So at that time when we start, we do one thing, we build one thing first, then another problem arises that changes our whole, it might change our entire way of thinking for the whole thing. So basically, and we also had that cost constraint. So with the budget you provided, we couldn't use a powerful processor, we couldn't use much powerful hardware. We had to build a basic thing. So that is where accuracy and all that movements that comes into picture. When you use such hardware, you have to think how to improve it with such a small budget.
Initially you must be frustrated, right? That look, hey, somebody else has designed it, somebody else has given me this budget, and somebody else has defined the logic also, and now this bearded guy is coming over there, now and then, and telling us that, oh, I want this alignment, I want this accuracy, I want this, this breathing, and breathing is the, battery, and we had this whole. But look, in the end it works, right? There are multiple kinds of technology now, right? One kind of technology, and especially in robotics, there's one technology which is very, very expensive, which is more related to calibration, accuracy, and all that stuff, right? Which huge companies use it, or it is fundamentally, if you look at space, it is literally governed by robotics, right? That is one expensive one. Second one is in the enterprise space, right? If you actually look at warehouse, if you actually look at manufacturing, automobile industry, and all this stuff, they may not be driven totally, but they are quite enabled by various elements of robotics, right? Even pharma companies now using the bottling plants and all that stuff. It was this third zone which I was pushing everyone, which was a commodity zone, right? If you actually look at any computing device today, right, that computing device will dwarf in terms of engineering, not in terms of science, in terms of engineering, any other thing which is there in enterprise space, and especially in information technology space, right? One of the things which I really love, that you have used cameras for path, right? Instead of very, very expensive sensors and too many of them, fundamentally alignment of cameras. So take us through what kind of batteries or cameras or various computational units you have used, which are more in a commodity space rather than in that expensive enterprise space, and that's why you have created this beautiful thing behind you.
What we have done is we have used very cheap components. Each individual components are accessible to almost everyone. Like hobbyists, they all use these Arduinos, Raspberry Pis, all hobbyists use it and they're quite familiar with that. But the problem is putting them all together into one single piece.
Yeah.
So that is the main constraint we had.
Yeah.
So
that's actually not a constraint, right? Because nowadays, a lot of computer science or so-called computer science engineers, they can make things easier, right? Because it's plug and play.
Yeah.
You buy this expensive thing, and or some people actually make it overtly simple. You buy everything from one manufacturer and they will assemble on their own, right? Or you buy these very, very expensive things with extremely, interoperatable softwares which come with them, and then you can do that. We never took that path, right? We said that we will go for things which are in the commodity space, with a child maybe using to fly their drones or something like that, and then we will write our own software and we will create our own ecosystem of an architecture. Hence, this is very fresh. Hence we call this as innovation, right?
So starting from the bottom, first of all, we have two motors. The motors are 12-volt motors. They are used to power the whole robot to move forward. They are used to move the robot forward, backwards, and left and right. You can move in 360 degrees. And we have a battery. A battery that is a LiPo battery, and we use that battery because it is very dense. It can hold a large amount of charge in a small area compared to the normal batteries which we use. So and then we have some obstacle detectors. We have ultrasound sensors and IR sensors. These are what everyone uses when they start going into the electronic field. So we have these sensors. They are used to detect the presence of objects or people who are moving forward, so that the robot doesn't collide into anyone. And the localization and the positioning we've done using we've done using certain Aruco markers. These markers are pasted onto the floor, and the robot has a camera to locate these markers. So when the markers come into the frame, the robot knows that each marker has an ID. So when the markers come into the frame of the camera, the robot will know exactly where it is right now and where it has to go. So each device consumes different amounts of power and voltages. So we have built our own battery management system to divide this power to all of the sensors.
Cool.
And then we have a barcode scanner, which is used to scan the barcodes of the passengers. We couldn't build one from scratch. So what we did was we took apart
and there was no need for it, because if you actually look, you can find a cheapest of cheapest barcode in a retail domain rather than into a specialized kind of domain. Or even today in normal phones, right? You can have all kinds of barcode detectors and readers and even printers to that extent, right?
So we took apart an existing barcode scanner, we placed it there, and the eyes are basically an LED matrix, and they're controlled by the microcontroller present, and we can provide different expressions to the robot using those eyes.
Cool.
So basically.
Perfect.